Haven't done too much on the Riley tonight, but I am sitting in it, just slowly trying to get a feel for what the seating position of this thing's going to be like. And it's pretty cramped. I don't think you'd be able to drive it with these sort of boots on at all, given the amount of room that you have in the footwell, although the accelerator pedal can be up here. I think there's meant to be a heel board under there because, of course, there's the chassis member there. And this is the steering wheel. And you can see everything's very tight. And this is the torque tube. So you're sitting next to this, and this is presumably going up and down with the rear suspension as you're driving along. You can see how low to the ground you are. So that's not even bending over. I can just touch the ground. It just fits over your legs. I can just see over the top of the steering wheel. Although if I'm a bit more upright, if my back's a bit more upright, I can see. And until the remote gear shift arrives, I'm not exactly sure where the gear change will be. It'll be down here somewhere. I'm also going to have to figure out the handbrake, because normally the handbrake would come off here and it'd be up here somewhere on a saloon car, so that needs modifying as well. It's sort of down here, a shortened lever handle, and I'm not even sure how you get out of this thing. So I'm still figuring out exactly where the back of the seat goes, but it is pretty much there somewhere. So other than sitting in that and making brum brum noises, the torque tube front bearing arrived today, so I do need to put that in, but I'm not going to do that tonight. It's a unsealed bearing because you want oil from the little trough there. That needs to be filled with oil, and some of that drips down onto the ball, and it also goes down the torque tube, which is running, it's pointing mostly downhill. Once the weight's on the back of the car, that's probably going to end up fairly straight. But some of the oil will go down to where the center bearing is, so it needs to be able to get through this one. Obviously this needs oil as well. So that arrived. I have ordered a new bearing for the Dynamo. I've measured the field coils. I haven't cleaned them up yet, but I have measured them, and sort of between 3 to 4 ohms, which seems about right. I still need to clean them up. If the worst came to the worst, I think I would be able to make new coils. People have done that before. You build a special little former and you sort of wrap the wire around it. This I have measured. So you check for conductivity between each of the segments in turn going around, so they should conduct, and you check each of the segments to the body to make sure it's not shorting out. So I think this should be good once I redo the string on this main bit. The brushes, I found an article which said there needs to be at least 1/4 of an inch, or more than 1/4 of an inch. So I think these brushes are fine. I still may see if I can get replacement ones, but they'll do to see if it works. I've ordered a sealed new bearing for that end. I'm going to reuse this bearing because this is already sealed and it's fine. It's I don't think that's ever really been used. And I also looked up the different years and the different makes of these Rotax dynamos. This is a later one, 35, 36, I think. The one I've got is a 1931, so it's much closer to the 1930 period I'm going for with this car. And the other good thing is they do all vary in nose length, this length here, how long this bit is, how long that bit is, but the driving dog and the mounting is the same on all of them, so they are interchangeable. You get a difference whether they're 2 brush or 3 brush, and effectively in how the wiring's done. So This one is a 3-brush one with 2 wires coming out of it. So effectively this dynamo, there would just be a cutout in the car, and all that does is, there's no regulator at all. The cutout just disconnects the dynamo from the battery when the dynamo voltage is lower than the battery voltage, because otherwise the battery would spin it like a motor, or try to, and a lot of current would go through it and it would melt all the solder off it. There is a modern semiconductor device. They use it on, it's to do with solar power installations and solar cells. Same sort of idea, where you want to disconnect the cells, I guess, if the voltage drops too much. I can't remember the name of the device off the top of my head. I've looked them up before. They came up in one of the Austin 7 forums. So I looked up the device and I looked up the data sheet for it, and it does work pretty well as a, effectively it's a diode, but it's a very low loss diode, more or less. So one of those may be able to replace the regular old mechanical cutout if I can't find one of those. I do have somewhere, probably up here, some sort of regulator cutout thing, which I don't know where it is at the moment. Green thing with a fuse box. I need to actually look that up and see what that is, but that no, it's in one of these boxes. That may be usable as well. The other thing I've done tonight is my camlock tool post finally arrived for my little lathe. The first one I ordered didn't show up, but they refunded the money. It got stopped by customs apparently. I've no idea why. So I had to order another one, which took forever to get here, but it arrived with another one of the standard tool holders. So I have 5 of those now, plus a sort of boring bar holder one. You can get different style holders for these, but this camlock comes with a I think it's, I can't remember what the thread is on this. I think that's 8mm or 10mm, but this doesn't fit my little lathe. So what I ended up having to do is, this has an 8mm stud effectively that comes up to about here, that the original tool post bolted to. This isn't the original one, this is my old one, which is a much simpler sort of wedge style. You just do up the bolt to lock these in, and I've never found them to be that rigid. But when I made this one, to get this to fit on that lathe, I made up this little collar that would drop in here, and the stud came up long enough that I could put the little locking lever on the top. So I made all this up. That works fine. This one is too tall, so the stud doesn't come all the way through. So instead I turned down a bolt. So this is a 10mm metric bolt. Well, actually it isn't. If I had a 10mm metric bolt, I would have used that, a high tensile one, but I didn't. So this is it's a 5/8, or rather it's a imperial bolt that uses a 5/8 spanner. I'm too used to Whitworth, where the spanner size is the actual thread size, not the head size, whereas this is a 5/8 head bolt that I had to machine down. So I was able to machine down the shaft of it so it was a very nice sliding fit inside the new tool post, and then I drilled through and threaded it M8. So this now screws down onto that stud inside there, but it also provides a sleeve for this. So if you loosen this off, this now rotates. I've got a hardened washer under there, and then you can just lock it in position. And this wedge lock cam lock thing works a lot better. If you move that like that, these lift up, and then you can remove these. The good thing is it's got 2 of them, so you can put a tool this side or this side. And this piece here actually has like a big thread on it, the same, almost like the same as the inside of the chuck, the scroll that the jaws ride up and down on. And that's what these have. They have the same sort of jaws inside there, or the same sort of thread part, which is what this is riding up and down on. So you get a very positive lock on it, and you can really lock these in. And the handle's in a good out of the way position, which is nice. And I've only done this one really quick test piece that's just mild steel, but it works really well. The only thing that does worry me about this is quite high on this lathe, and so sometimes I'm worried if I can get this to go low enough. And I actually had that problem with this one too, and you can see on one of them I milled it so that I could drop this down lower than the edge of this, which was occasionally I needed to do that for some reason. I can't remember exactly why I needed to do that, but it did happen from time to time. So that's the only thing that worries me about this, is being able to get it to drop low enough. But I think it should be fine. So that's good, that's finally arrived. The wire wheel is arriving for this shortly, and this I'll probably take out of here now. I don't want to leave it in the degreaser for too long, even though it should be pretty safe. And then that can do with a clean up and a repaint. I think when I do reassemble this, because it's all been taken apart and it probably hasn't been used for years, you have to reflash it. The way these dynamos work is there's no permanent magnets. It powers its own field coils, but you need a certain amount of magnetism in these to start that process off. So if you change the polarity, or it's been sitting for a long time without being used, you have to do what's called reflashing it, which is where you basically just put it straight across the battery just for a second, and that will magnetize these, so that when the dynamo does start spinning, there's already a little bit of magnetism in there, just enough to start the current flowing, and then it sort of feeds back and builds up to the full operating voltage. That's the theory, at least, and obviously I've got no idea if this is going to work until I clean it all up and put it back together. So the question is, do you spend all the time cleaning it up, making it all nice, painting it, make it pretty, and then find it doesn't work? Or should I put it together scruffily, and then if it works, clean it up? I'm not really sure what's best to do. I'm back out working on this dynamo again. It's a rainy day, so it might be a little bit loud. I have cleaned up the coils as best as I could. I just used a little bit of brake cleaner on a rag and rubbed the rag on the coils to get most of the oil and grease off. And I've removed all of the old insulation. This is all old and brittle, and I think some of this tape was added later. I'd say this was definitely added later by someone. That seems like it's PVC, and that's gone all hard and brittle. It also looks like it's been repaired at one point, because there's a splice in the wire there which it's just twisted together. It's not even soldered. But I suspect this is some of the original insulation, and as you can see, it's just gone. Pretty sure these will be the original joins between the coils, where it's soldered and twisted together. And I do find it tricky to measure the coils, such low resistance with my digital meter. It doesn't really work that well. But the coils all seem to be giving me about 1.2, 1.4 ohms. And with the insulation off, I can measure them all individually, and they do all seem to be okay. They're not shorted out. I have a new bearing on the way, and I did look more closely at this and discovered that the threads were stripped. The two screws that were there had stripped threads, and the one screw that was missing wasn't stripped. But I did consider getting new screws and drilling new holes and tapping them. In the end, I discovered that the hole size was so close to M4, I was able to just run an M4 tap down, recut the threads, and I'm going to use M4 socket head screws, countersunk ones, which is kind of breaking one of my own rules about no modern fasteners on a vintage car. But these are hidden, so you won't see them on the car because this faceplate goes onto the engine like that. So those ones I'm not too worried about, because once they're in there they should never have to come out again until it's time to change the bearings. These I did actually leave soaking in the degreaser for a little bit longer because it started taking the paint off, which is actually what I wanted. So the paint's been taken off those. I ran them through the sandblaster on the outside and I wheeled them, and for now I've just given them a rub down with Penetrol before I decide whether or not I'm going to paint them. They've cleaned up really well. The rotating part, I've reattached or redone the cordage around it. This is cable lacing cable, so it's very, very strong. And I was able to get quite a lot of tension on there. I've super glued the ends where it's tied together. And before I go in tonight, I think I'll give it a quick coat of polyurethane varnish just around here, which I think should work fine. Sort of like spa varnish. I'll see what I've got and what's going to be suitable for that, but I think this will be fine now. And I think that's about it. Once this bearing arrives, I can start reassembling it and see if it works. I'm going to re-insulate all of these wires. It has got a little bit thin on these windings in a few places. I'm trying not to move them too much to not stress the wires. So I think what I'll do is I'll rewrap these, or wrap over these. I'm not going to remove what's on there, but I'll wrap over these with a layer of modern Kapton tape because it's very thin and very strong. So that'll hopefully seal them up and hold them together nicely. I will re-insulate the bare wires, probably with some cloth loom tape over a layer of Kapton. And then I think I just need to chuck it all back together and see if I can get it to work. So fingers crossed that actually does the trick. Finished taping up the field coils. I did use Kapton tape on them first, which was a little tricky because it wouldn't stick to the old coils. It would only stick to itself. And of course the other difficulty is you're trying to wrap something that's got a hole that big in the middle. So I had to cut strips of it, just short lengths, and then wrap them around. And then I went over it again with good quality loom tape. This is like cloth loom tape. And I've spliced and soldered in new wires where the old ones were all mangled. The tricky thing, the only thing I had to be careful of with the tape was not getting too much tape on the inside, because you still need the metal pole pieces to fit through, of course, and you don't want any tape on the back so that these pull up really tight against the inside of the casing when the time comes. That shouldn't be too bad because these are actually bolted in and not screwed in, so you can get a bit of torque on those. The only thing I have to try and remember is which way round this goes inside the housing. It also seems fairly loose. I don't know if that's meant to be a press fit or not. It seems a little bit rattly. Whoops. So I'm not sure if that's correct, if that's meant to sort of float like that. I wouldn't have thought so. And I'm pretty sure it must go in that way, not that way. Because if it goes in that way, it's not going to be pressing up. Well, I'm not sure. That's the thing. I'll have to look over my pictures of my film of when I took it apart to see which way round it was. But given the state this was in, there's no guarantee that was correct. So I'll have to see if I can find a picture of the insides of one of these, which I haven't so far. So yeah, that's going to be interesting. Given this one went that way, no, I'm not certain. I've measured it, and this does fit through that hole. So I suspect it's supposed to go that way. Like I say, I really don't know. And it may have been something to do with the open bearings that they used back in the day. And this is supposed to kind of help stop oil getting in there or out of the bearing or something. So I'm not sure it matters so much with a sealed bearing. But like I say, I'll look that up and see if I can figure it out. So hopefully I can start putting this all back together again. Oh, I still need to do the coating on that. It does look like just normal varnish. I do actually have old-fashioned shellac type stuff, but I'm pretty sure just any modern polyurethane is going to be fine on there. I'm just not sure what sort of heat that those can take, but these shouldn't be getting too hot anyway, I would think. I've been searching through my parts trying to find the drive dog. I'm sure I've got one loose somewhere. I just need to sort through the boxes of parts and try and find it again. But I did find two other things of interest. One was this, and a tin full of old nuts and bolts. That, I've just cleaned it up. My little wire wheel finally arrived for my little angle grinder, so I cleaned it up on that. This, I believe, is the little nut that goes on there. I have no idea if that's original or if that's something that's been cast up since. It's definitely a cast piece, but that works well, so I'm going to go with it. The other thing I discovered, which is related to the Dynamo, is I have this. It needs cleaning up and repainting and everything, but this is a Lucas fuse and cutout. So this is a 12-volt cutout. I'm not sure if it works or not. I can test it on my adjustable power supply. But the idea of this is what disconnects the dynamo from the rest of the car, from the battery effectively, when it isn't generating enough voltage. If you connect a dynamo like this up to a battery, it'll actually work like a motor as well. Or it'll try to. What would happen is the battery will feed current back into this and it could burn itself out. The idea of the cutout is to not connect the dynamo to the rest of the car's electrical system until it's producing enough voltage that it's actually going to charge the battery. And that's what the cutout does. It's a simple relay. Well, actually, they're not simple. The science in these things is really quite fascinating and quite interesting, how they manage to make it so that it cuts on and off very accurately and sharply. But effectively, it's just a coil and some contacts. And these contacts will close when the voltage is high enough that the dynamo can be connected to the rest of the system. So this is an original one. I'm not sure if it's exactly right for the Riley, but it will work. And it also has a very old school fuse arrangement. It's actually just using a fusible link or fuse wire in there, not a cartridge fuse. So I suspect this is fairly old. I don't know if it's got a... Usually there's a number on them somewhere. There is. It's just a little bit hard to see. It says 28. It says 12 volt, 12 VER, I think. But I'll see if that works anyway, and that might be very usable in the car, and I think it is actually pretty close to correct. I've been searching through my parts trying to find the drive dog. I'm sure I've got one loose somewhere. I just need to sort through the boxes of parts and try and find it again. But I did find two other things of interest. One was this, and a tin full of old nuts and bolts. That, I've just cleaned it up. My little wire wheel finally arrived for my little angle grinder, so I cleaned it up on that. This, I believe, is the little nut that goes on there. I have no idea if that's original or if that's something that's been cast up since. It's definitely a cast piece, but that works well, so I'm going to go with it. The other thing I discovered, which is related to the Dynamo, is I have this. It needs cleaning up and repainting and everything, but this is a Lucas fuse and cutout. So this is a 12 volt cutout. I'm not sure if it works or not. I can test it on my adjustable power supply, but the idea of this is what disconnects the dynamo from the rest of the car, from the battery effectively, when it isn't generating enough voltage. If you connect a dynamo like this up to a battery, it'll actually work like a motor as well, or it'll try to. What would happen is the battery will feed current back into this and it could burn itself out. The idea of the cutout is to not connect the dynamo to the rest of the car's electrical system until it's producing enough voltage that it's actually going to charge the battery. And that's what the cutout does. It's a simple relay. Well, actually, they're not simple. The science in these things is really quite fascinating and quite interesting, how they manage to make it so that it cuts on and off very accurately and sharply. But effectively, it's just a coil and some contacts. And these contacts will close when the voltage is high enough that the dynamo can be connected to the rest of the system. So this is an original one. I'm not sure if it's exactly right for the Riley, but it will work. And it also has a very old school fuse arrangement. It's actually just using a fusible link or fuse wire in there, not a cartridge fuse. So I suspect this is fairly old. I don't know if it's got a... Usually there's a number on them somewhere. There is. It's just a little bit hard to see. It says 28. It says 12 volt, 12 VER, I think. But I'll see if that works anyway, and that might be very usable in the car, and I think it is actually pretty close to correct. They have the cutout set up in my little lab, hooked up to my adjustable power supply there. Currently there's 6 volts going into it, so there's a tiny bit of current flowing. Oh, this is the remains of the insulation that came off the brush wires. It all just broke up. But I can adjust the power supply, turning the voltage up, and we should see this click in. Oops. 8, 9, 10, 11, 12, 13, and then it clicks in. And then if you wind it back down, there's hysteresis built into it. So it's at 8 volts, and then it clicks open. This power supply it works in steps. It's a digital power supply, so a variable power supply would be better to show this, because you could wind it up and down and see exactly what the voltage is. But I do have one, but unfortunately I kind of blew it up with a Van de Graaff machine. I blew up the display, so I could get that out and set up a voltmeter on it. But for now, as a quick test, that shows that this thing still works, and this is probably very usable in the car. I've managed to free up the old bearing enough that it rotates fine. I wouldn't use it in the car, but it's okay just for this testing. And the other thing I had to do, which was explained in the instructions, is there needed to be a spacer on the bearing on this end. So to position it out, to make sure these didn't, the contacts here didn't rub on the housing. And I put it back together and I sort of measured how big that spacer needed to be. And on this it seemed to be 1/8 of an inch. So I actually had a hardened steel washer that I was able to fit in there to use as a spacer. And that's worked well. It's only temporarily put together. I have flashed it, but unfortunately it doesn't seem to be working. So the most I can get out of it spinning it is about 0.1 of a volt. If you disconnect the field and just measure the output, the residual magnetism, when you spin it at about 3000 RPM, it says you should be getting about half a volt. So the fastest thing I've got to spin it with is this electric drill, which does 2800 RPM. And I had to make up this drive dog thing. It's just a piece of steel tube and a little piece of mild steel machined down, pushed in the end. It's just Loctited in place, which is holding fine. And I just milled a 10mm slot in the end, and that can fit down in there and engage with the shaft, and then I can spin this up. You can hear the noisy bearing. So I get a tiny voltage. But that's not enough. And with the field connected to the dynamo output like that, it should be generating actual voltage. I've tried playing around with the brushes. So this is one of the main brushes. You can adjust these backwards and forwards a little bit, and that makes a tiny difference. If I go slightly more that way, I get a slightly higher voltage, but not really much. So I don't know what that means. I think that means the armature is no good. The field coils seem okay. There's conductivity there. I tried flashing it with the ammeter across it, and it definitely drew some current. So there's no break in those, unless one of them shorted or something. But when I measured them all separately, they all seemed about right. The only thing I can think of trying is possibly rotating the field coil's position around one, but I don't think that's really going to make any difference either. It's worth a try while it's relatively easy for me to take this apart and put it back together. So I may give that a try and see what happens. So I may end up having to look at the second dynamo I've got and seeing if this one's any better. Of course, this is the long nose one, and unfortunately my little drill driving dog thing isn't long enough to fit. So I'd have to make up a little extension for that. But it may be worth seeing if this one generates anything just as it is. Okay, moving the coils around one position, which effectively swaps the norths and souths around, gave me the exact same voltage, just negative. That probably should have been apparent to me before I did that, but it was worth trying. It's all learning. So I'm going to put the field coils back to where they were. The other thing that's interesting is, I think I mentioned before, a dynamo is basically the same as a motor. And if I connect the field and the dynamo output together and actually put it across the battery, it does spin. It spins like a motor. So I'm wondering if my problem is I just can't spin it fast enough with the drill, or there's something a bit odd about my digital meter trying to read the voltage. I don't actually have an analog meter. I think I've got some old analog meters around, or maybe I can find an analog car voltmeter and just try that across it, because maybe the digital meter isn't quite telling me the truth. The other thing I could do is put it across the oscilloscope and see what's happening, I suppose. But I'm going to put the field coils back to where they should be, so it actually generates a positive tiny voltage, and have another look from there. Well, I'm kind of stumped for now. I tried reflashing it using my battery charger, just in case this battery isn't good anymore. It was picked up off a pile of batteries that was being thrown out at one point, so I'm not sure how good it actually is. It runs the bead roller okay though. When I switched the coils around again, I also remeasured the contacts on there, and they're definitely all there, and there are definitely no shorts to earth. When I did reflash this, it did spin very slowly as a motor. So it is kind of working. I've also tried a different meter. I actually tried this ancient voltmeter, which I didn't even know if it worked or not. I put it across the battery and it did work. And that's not registering anything either. And I also tried this 12 volt, 21 5 watt bulb just to see if that would light up. And it doesn't. So I'm not sure what else I can really try. I've also I filed the ends of the carbon brushes just to make sure they were okay. Measuring resistances of things, it seems okay. So if I measure the field coils, I get about 4 ohms. It's kind of strange how it drops a bit like that. I really want to get a decent analog meter. I've tried checking for shorts. So this is the D output, and if I take the brush out, there's no short between there and ground, so it is going through the armature. Yeah, like I say, I'm really not sure what else I can try. The only thing I can think of is it's just not spinning fast enough. But I think unless it needs at least 3,000 revs to really kick in, I would have thought I'd see something on it. So the next thing to try would be driving it from the mill, possibly. My lathe, I don't think it doesn't go fast enough. It only goes to 2800 as well. The mill should be able to go a lot faster. No, that only goes to 2150. So yeah, I'm not sure what I can try. I might try extending that thing and just try this one and see if this gives me anything different. But I think I'm a bit overplaying with it today, so I was hoping to finish this with a triumphant showing it running sort of film, but no, it's not the case. But I do know how to strip and put back together one of these dynamos pretty quickly now.